So to evaluate this derivative, we should use properties of logarithms first, because otherwise take a derivative of the outermost function, then the product rule, and then chain rule again, and then chain rule again. It's crazy. It's way easier to do this with the properties of logarithms. Before we do that though, this is very well may be the first time you've seen the derivative of natural log. So the derivative of natural log x is just 1 over x. But the chain rule applies, okay? Whenever you take a derivative of a logarithm, then it's always the reciprocal of the argument, so the reciprocal of the thing inside the parentheses. But the chain rule always applies. This is the derivative of the logarithm part. The derivative of the innermost part is 2x. So that simplifies to be 2 over x. Okay, so that's the basics of differentiation with specifically natural log. With a common log, with common log or any other logarithm, it's not too much different. It's just you need to chain on a logarithm of the base at the end. A natural log of the base, I should say. Either way, we'll do that in another video. So this one, before we do the calculus, let's do some algebra. I'm going to distribute this, not distribute, whoa, wrong word. I'm going to use the multiplicative property of logarithms. 7x times the square root of 7x means that we can separate it like this. And now I'm going to use the power property of logarithms. This is all to the 1/2 power. So instead I can move that 1/2 and have it multiply on the outside as a coefficient. Now things are easier if I want to evaluate a derivative, because with derivatives we can go term by term. It's kind of like it can distribute. So the derivative of natural log 7x is going to be 1 over 7x, but then times 7 because of the chain rule, right? Innermost function derivative is 7 there. And over here, it's natural log, the derivative of the natural log means it's the reciprocal, so it's 1 over 7x plus 4 times the derivative of the innermost function, so times 7 there. So 1 over 7x times 7 makes 1 over x. Then over here, we're going to have 7 over 2, let's just distribute that 2 times everything in here. That's 14x plus 8. Or I guess you could keep it factored either way, but there is our derivative. I just checked Newton's answer. This is right, but they also combine it. I don't know why. I don't know whether it's going to mark it wrong if you use this answer, or we could expand it like I'm about to do here. With the left fraction, I'm multiplying the top and the bottom by 14x plus 8. Right? A perfectly legal move in math, because I'm doing the same to the top as I am to the bottom of the fraction. It's still in proportion. And on the right fraction, I'm multiplying everything by x, the top and the bottom by x. And now we can combine the numerators. Oh wait, 14x plus 7x makes 21x plus 8. And then I think they distributed in the denominator. They made 14x squared plus 8x. Either way, it should accept this, should accept that, should accept it if you did distribute it. It's somewhat user-friendly in that regard. So again, using the properties, now this is the division property of logarithms, the quotient property, I think is as it's sometimes referred. If you have two things being divided, you can separate them with subtraction instead of addition, which makes intuitive sense, right? If two things multiplying means you separate them with addition, two things dividing means you separate them with subtraction. So the power rule can apply here. Make that 2 come down. And now we can evaluate the derivative. So the derivative of this is 2 over x minus 4, and then normally this is where we do the chain rule, but the derivative of the innermost function is just 1. So nothing to write there. Then here, it's 2 over negative x minus 3. Now the derivative of the innermost function isn't nothing, it's a negative 1. So we've got 2 over x minus 4 plus 2 over negative x minus 3. But let's do what they did with the answers last time. Let's get common denominators. So I'm multiplying the top and the bottom of the first fraction by negative x minus 3. and then the top and the bottom of this fraction by x minus 4. And now we can combine. If we distribute, that's negative 2x. That's a positive 2x. So those are just going to cancel each other out. And then 2 times negative 3 makes negative 6. 2 times negative 4 makes negative 8. So negative 6 plus negative 8 makes negative 14 in the numerator. And it's all over this stuff in the bottom. But like I said, go ahead and try, because you get 2 chances when you type them in, so that you don't have to do all this. Go ahead and try just stopping here and typing that in, but if that doesn't work, this is how they formatted their answer on my side of things. So I'm just going to get you started on this one. Using the properties of logarithms. Remember, a fourth root means it's a 1/4 power. This is all the 1/4, and then it's a logarithm of this whole thing. So what you'll want to do is first use the power property of logarithms, the exponent property, I guess it's sometimes called. So that gets rid of the 1/4, puts it out front. And then we can use the quotient property of logarithms. This is natural log x minus 2 minus natural log 5 minus 10x. And now you can start doing some calculus after that. Now you can evaluate the derivative of each term like we did in the other problems.